Projectile review. So we're going to talk for just a second about projectiles. Let's assume that we have a projectile launched with some velocity at some angle. The first step is to remember that the velocity in the x direction and the velocity in the y direction are independent. The velocity in the x direction is given by v0 cosine theta, and the velocity in the y direction is v0 sine theta minus gt, where I'm assuming g is positive 10.10 meters per second squared. So a couple key ideas. Velocity in the y direction at the top is equal to 0. And we can use that a couple different ways. One way is if we want to know the maximum height, maximum y, I can use the fact that vy squared is equal to v0y squared plus 2 a delta y, and then since the velocity at the top is 0, I can just use this equation and in essence get that the v0y squared is equal to 2 times g times delta y, and that's going to get me to my maximum height. Another way to think about this is that as the ball goes up, as the ball goes up in the air, its velocity is decreasing, and it decreases. The g is 10 meters per second squared, minus 10 meters per second squared, which says, for example, that if I have an initial velocity in the y direction of 15 meters per second, that the time to the top is going to be 1.5 seconds. And I can use that to also get the top. In this case right here, I could, for example, say that going up, the average velocity is 15 plus 0 divided by 2, and therefore the total height, I just wrote it, d, is equal to 7.5 times 1.5, and that will give me my maximum height. Let's look for a second at the what goes on in the range, in the distance equation for range. So we know that if the final and initial heights are the same, we can use the range equation v0 squared sine 2 theta divided by g, but that requires y final to equal y initial, and that's not always the case. A more straightforward, or I guess a more robust solution for the range is to determine the time for y final. So if you know the final height of the ball, determine how long it takes to get there using the y is equal to y0 v0y times t plus 1/2 at squared equation. And then once I've done that, I can say that my range is equal to the velocity in the x direction multiplied by that time. I'd have to solve this equation here. Has to get solved for time. That will give me my range, and that's going to work anytime at all. You might want to include x0 if you for some reason are saying you start at a non-zero x0. The two other points that are worth remembering when we do this stuff is that the velocity at any point is given by vx squared plus Vy squared, that the angle is given by Vy over Vx, and that's equal to the angle, and that if I were to draw my projectile in, the important idea is that the velocity in the x direction is constant the whole time, but the velocity in the y direction changes. You might start out with a big velocity, it's going to get smaller, it's going to be 0 there, coming back down again. If you're at the same height, the velocity should be the same, and at the bottom the y velocity is equal to the initial y velocity, except one is negative and one is positive.